All right, let's see. All right, for those just joining, sorry I was a little, hey, there's Eric. Hey, how are you?
Good, how are you?
I am great. You got the t-shirt in time.
I do. I got this mail today. I didn't think it was going to make it, but it actually arrived right before the talk. So I put it on. I'm ready to go.
Awesome, awesome. All right, let me see. I just took a break, so I'm just getting my bearings real quick.
Okay.
All right, for joining us, this is the Salt Masters in AWS, a cattle not pets approach. We'll give it a few more minutes and then get started.
Sounds good.
Awesome. Well, I hope everyone's having a great SaltConf so far. I've been in some great talks, and I expect the ones that even I didn't get to are also great. So it's been a good day so far.
Hopefully, I can watch some after the recording because I've just been.
I know, right? You want to catch them all. And so far, all the demos I've seen, the live demos have worked out well too. So that's lucky.
Yeah, I was going to record my demo, but I was messing with it just now. So, knock on wood, no dependency changes or anything in between now and 5 minutes ago.
All right, I'll just set some ground rules. All right, so my name is Dave, and I'm on the Enterprise Salt product team now at VMware. And as everyone's kind of joining in, you can feel free to chat us up in the session room there. Let us know where you're from, any questions or anything you're expecting out of this talk, and just to make this a little more interactive. Because Eric and I will be looking at for questions, and if there's time at the end, we'll get to those. You're probably familiar with the platform so far. You can double click on different windows to make them larger. And with that, all right, so I will introduce Eric here. All right, so Eric is a Linux system engineer with 10 plus years of demonstrated experience working in the IT industry. Skilled in Linux, shell scripting, Perl, Python, Ruby, networking, and IS, primarily using a combination of Linux, networking, and development technical expertise in DevOps and SRE-centric roles, supporting SaaS products and hosted in AWS. All right, hopefully you're in the right place. And all right, Eric, I'll hand the time over to you, and I'll look out for questions. And
all right.
And all right, take it away.
I'm going to share my slides here. I noticed that it does a little bit of artifacting, so I'm going to share it now instead of previously. Okay, so just an intro. The title of this talk is Salt Masters in AWS, a cattle not pets approach. The abstract really focuses on ephemeral salt masters hosted in the AWS Cloud. I will caveat that this talk isn't necessarily for anyone that's new to AWS. It does assume some familiarity. We'll get at the end, we'll talk about all of the available documentation that you can follow if this is something that interests you. But I just want to put that up front that this is not a intro to AWS. This relies on a couple of intricate AWS services to achieve the ephemeral salt masters that we'll dive into here. A little bit about me, a little bit more about my background. I'm a systems development engineer at AWS. So at AWS, that's a role that kind of combines systems engineering with development. It's analogous to a DevOps engineer in the industry, although that is a kind of a nebulous term and can mean different things for different companies. At AWS, it combines systems engineering with software development and managing and maintaining services with code, developing features, that type of stuff. I work on a team, and my team is a small, scrappy team, and we run an internal AWS service. The fun thing about our team and our service is that it actually is an AWS service hosted in AWS, so we use a lot of the AWS services that any other commercial user of the AWS Cloud could use. So that means that this talk that we're going to talk about, it directly translates to anyone who wants to go and use these AWS products in their own account, in their own environment in the cloud today. Prior to working at AWS, I was also the nebulous DevOps engineer for a single wire software and Zendesk. Both of those are SaaS-based products that run in AWS. So I've had a good amount of AWS experience. And this talk may take that for granted a little bit. At the end, we'll talk about some sources if this is something that you do want to do. Before all this, I started as a Linux systems administrator. That's my bread and butter. That's what got me started. I love Linux. I love networking. I love configuration management. I've used CF Engine, Chef, and Puppet. Maybe it's a little blasphemy to mention those at SaltConf, but I've had exposure to all of those. But I haven't had much exposure to Salt. I actually just started using Salt this year. My team kind of needed a lightweight yet powerful configuration management system. Like I said, I've used some of the other ones in the past, and they were kind of heavy or inappropriate for our use case. So I looked into Salt and a couple of others, but Salt really stood out to me. I thought it was the speed and scalability of Salt really was impressive to me, and it really caught my attention. It was easy to manage from 10 nodes to 1,000 nodes, and the speed was incredible. And that right there kind of sold me. I really liked that it was agent-based and easy to bootstrap new instances. And given my team and our product, what we're doing is we have a lot of instances that come up and down that can auto-scale, and we wanted a way to be able to have those check into the Salt Master and get their roles, get their configurations, and then when they went away, they would go away, and then the next time they came back up, their configurations would be sent back out to the new host. And Salt seemed like it was this great mix of powerful yet lightweight. It stood out from the others because of the lightweight ability, yet it still gave you some functionality that some of the bigger configuration management engines provide. So I started thinking about integrating Salt into our service. Our service, as I said, we use hundreds of nodes all in EC2, and the way it works is that a lot of our services will need to be bootstrapped for a specific role. So we manage all of those roles in code. So this can't be something that integrating Salt had to be something that was automated. It was CI/CD. It couldn't be something that you built by hand. So the idea kind of came in of like, how can we take the Salt Master and build it into our system that is highly elastic, that has instances coming and going, and build it into the Salt Master and make the Salt Master kind of elastic. So as I said, we use auto-scaling groups to kind of leverage that. So our infrastructure comes up and down as we need to kind of scale the demands or replace instances. And the idea came that what happens if we took the Salt Master and we put it into an auto-scaling group as well? So we treat the Salt Master just like we treat our other infrastructure components. And the Salt Master isn't any more special than a minion or any other component in our infrastructure that's elastic. So this idea came to me, let's put them in the auto scaling group. I scoured over the documentation online, joined the Salt Slack channel, and just searched around generally. I did find one 2015 post asking if something like this was possible, which with very limited replies, and it kind of made me sad. And I thought, this is still something cool. I want to see if this is possible. So I scoured some of the Salt documentation. I have some links later to some of the useful documentation, but a couple of things that stood out to me was the master type of failover, master tries, master keep lives, and then preserving the private and public keys for the master. And I thought with those things, even though the documentation for this approach isn't out there and it seemed novel or very limited in its use case, given the things that I was seeing in the Salt documentation, I thought this is probably something that could actually be done. So I set up an experiment. I put it in I kind of labbed it up. And that's when the meat and potatoes kind of started. I said, how do we actually achieve this? One of the things, as I mentioned, is auto scaling groups. But we also need to think about other requirements. So I was thinking, so if the Salt Master goes away, how do we get the minions to think about them? So one of the requirements in my experiment and building it was that the minions must be unaware that the Salt Master changes. And when the new Salt Master comes up, it must quickly have the minions report into it. And keep in mind, this all happens automatically, no human intervention. We have hundreds of nodes, and we don't really want to manually go in and restart a Salt minion or have to accept keys on the Salt Master or anything like that. It also had to be deployable and repeatable. My team at Amazon, at AWS, we operate in several regions. So we need to be able to replicate what we do from one region to the next to the next. So this is something that can't be fragile, need to be durable and robust and be able to be carried out in any other region that we want to go to. So kind of with this experiment, putting it together, said this is definitely possible. Salt documentation looks like it can occur, can happen, but what are some services that can help us? So the first service that I kind of thought about using was the code pipeline. We'll dive into each of these in a little bit more detail, but the idea was that we can leverage some of these services to achieve this goal, specifically the code pipeline to knock out the CI/CD requirement. We could use the auto scaling groups and launch templates specifically in the auto scaling groups to elastically launch and terminate the Salt Master or the minions. And then we can also use Route 53 to manage the Salt DNS record. So most minions by default check into that record. So if we make that entry in Route 53, the minions can find the Salt Master easily. And then using Secrets Manager to store the actual master private and public key. So when there's a new master, it can fetch these and install them, and the minions are none the wiser. If we look here, this is kind of the overall diagram of this idea and how it's implemented. You can see way over on the left, we have all of our code in Git, hosted in code commit, which is basically a repository for code. That is the source of truth. So any Salt configurations will get pushed into there. It then moves to code build. Code build will package up our Salt configuration changes along with a couple of scripts that are used to achieve moving the files that we'll get into a little more on actual Salt Master. Once the artifact is built via code build, it'll be shipped to code deploy, and that's integrated with a auto scaling group, specifically the Salt Master auto scaling group, so it'll deploy directly to the Salt Master. Once it's on the Salt Master, obviously within a couple of minutes of that change, the minions will pick up that change, and they'll accept the newly pushed configurations. So kind of with this theory in mind, of how this works. I'm going to walk into each one and what I did to actually get this to work in the AWS Cloud. Said code commit is the first thing. That is the source of truth. That is where all of the salt configurations lie. So if you want to make any salt states, they go in this package. So this is one of the keys to making it ephemeral, because the configuration doesn't actually reside on the salt master. It resides in code and gets pushed to the salt master whenever there's a new one or whenever there's a change to configurations. So that's one of the keys. If the salt master isn't the source of truth and it's in code, it allows it to come up and go away a little more seamlessly without having to worry that, oh no, this configuration that we pushed on the salt master didn't get captured, and now your configurations are out of sync. So we look really closely on the right. That's just a tree of the files in the actual package. And that includes a couple of interesting files, AppSec and build spec. Those are specifically code build and code deploy dependent files, and we'll look at those in the subsequent slides. We've got our salt state. So as I said, anything that you want to configure in salt will go here. On the right, this is just a little bit of a demo. So clearly there's just a couple of things managing a few of the minions, just to kind of give a proof of concept. And as I said, all of the configurations get made here. So nothing gets changed on the salt master, nothing gets changed hot on the salt master, it's all in code. And then once you make a change, once you make a git change this and you push it, it goes to code commit, which triggers a code build. And when code build kicks off, it takes our changes, follows the build spec, and kind of bundles them all up. So it takes all of our scripts that we need once we get on the box to put these in place on the salt master. It takes all of our salt states, all the files we're shipping, it lumps them all and basically makes a deployment artifact. So this deployment artifact then gets shipped to our salt master via code deploy. If you look on the right-hand side, this is a specific code deploy configuration in the AppSpec file. This basically says at the top, it's in order, move all of these files that we just bundled with code build and put them in this directory. So that takes all of our salt files and configurations and drops them off on our salt master. The next thing is that some of these scripts that we see subsequently under the hook section after install and validate service, those actually take the deployment artifact that is now on the salt master and they move it to the proper location on the salt master. So in this case, serve salt, where we're actually serving up new files. Some of the other things in here we'll go into a little more, but yeah, we'll just walk into them right now. So the first thing we have is the salt master setup. I did have an environment backup that basically just took a snapshot of the old salt configurations and files and stored them somewhere, but that's not really interesting, so I kind of skipped that. The salt master setup is really where it's interesting. So once we have this deployment artifact onto the host and set up, the first thing it does, it fetches the keys from the secrets manager. So it actually goes out and says, hey, what are the salt master public and private keys? It gets them and moves them into the proper location of the salt master. Then it takes the salt directory, which includes all the files and states, and moves them to the proper root directory for salt. Once that's set up, the next thing is, so this is just kind of an example of secrets manager where it's storing the public and private keys, so store them in there, and then you can retrieve them using Boto 3 or the AWS CLI or any other SDK. And this really allows for the salt master to come up and down and be consistent. As long as the keys match, the minions aren't aware of the change. So after we've kind of moved everything into place, the next step is we start the salt master with the newly pushed configurations and files. We do a couple of health checks there first. We make sure that the salt master actually can start. We do a couple of lint checks using some of the salt built-in things to check the states and make sure they're good, because if someone pushes a bad change, you obviously don't want that to be pushed out to the rest of your fleet or impact the salt master from being able to start. So lint checks are taken into account before we start it. And then if everything passes, if all the health checks look good, all of our newly pushed salt configurations and files are in place, we'll start the salt master service. And then the next step is we do a couple more health checks, robust health checks after the service is running to just ensure that it stays running and that it's actually serving up the files that it's supposed to serve. After that, this is kind of the next key here, is that once we have everything in place, we validated that the configurations are complete and the salt master will start with the new configurations, we update the DNS record. So the minions check into the salt DNS record. But once we're up and running, let's say this is a new salt master that's replacing an old one. It's going to say, hey, I'm a new salt master, and it'll take its new IP address and it'll update it in Route 53. This allows the minions to then find the new salt master, kind of using some of the failover and retries to kind of find the newly replaced master. And although failover does kind of imply more than one salt master, with some of those configurations that we looked at, you can actually get it to be use just one salt master as a replacement. This is just an example of using the Route 53 and hosting salt in your VPC so that all minions can actually find this DNS record. And just to reiterate, once a deployment is done, a successful deployment is done, if it's a new master, the DNS record is updated with the new IP address so all the minions can find the master quickly. We also lower the TTL. You can lower it 60 seconds as recommended, but that'll allow minions to actually find it and talk to the new master a little quicker. In the demo, I have it toned down a little. I have it dropped a little lower just to increase the speed of the demo, but we'll look at it in more detail once we get there. So one of the biggest tools that we rely on to accomplish this, aside from the code pipeline, is auto-scaling groups and launch templates. So the launch templates allow us to install and basically bootstrap the host at first. So that includes installing Salt. And we leverage some other things we'll talk about in a minute. But by using launch templates with auto-scaling groups, we can spin up a base instance and say, this instance should install Salt minion and a couple other things, and maybe ship a basic Salt configuration for the minion so it knows what to look for and how to check into the Salt master. So right in this example on the right, you can see that we have a Salt master auto-scaling group. For simplicity, we have a desired min and max of 1, but you could use this for multi-master as well. You could have several masters, and the beauty is that because the configuration is coming in from code commit and pushed all the way through, your multi-masters will stay in sync. So if this was a really big environment and you wanted to distribute the load, you could clearly put 3 max Salt masters in here, maybe leverage an ELB, a load balancer of some type. In this demo, in this presentation, I just keep it simple and talk about one Salt master with a auto-scaling group of a min and max of 1. And one of the beauties about the auto-scaling group as well is that it integrates nicely with code deploy. So in this case, once you make your Salt change and you push it through the pipeline, as soon as it's built and ready to be deployed, it targets the auto-scaling group for the Salt master and pushes any new changes. So you don't have to, on the Salt master, you don't have to pull for changes. You don't have to wait. It's not a manual process of, oh, there was a deployment, let me go fetch it. It actually, as soon as it's built and pushed, it targets the Salt master. And then as well, it could also, if you're doing this in a multi-master type of setup, it would also target all the masters at once if you wanted, or you could do like a rolling kind of fashion where it does one and then the next. But integrating code deploy with auto-scaling groups also was a key in being able to achieve this functionality. Kind of moving on. We've talked a lot about launch templates. The launch templates are kind of one of the key components as well, because when your basic EC2 instance comes up, it has no configuration. So there's a couple other tools you could use to leverage this, but for simplicity, we just use the launch template for this demo. And what it does is it makes sure that Salt is installed, so it bootstraps the node. It ships a basic configuration to the box itself. So when the Salt minion starts, it has a base configuration. You can then check into the master and get a new configuration. So this is a kind of a temporary configuration, just enough to get it up and running, discover the master, and get its configurations. So one of the things that we interestingly leverage is actually using EC2 tags and EC2 metadata to actually create salt grains. So one of the things we'll talk about and see in the demo is that we have a tag of a minion and we have a tag of master. Clearly, this is just for demo purposes. In a real environment, maybe you would have several roles for several different infrastructure types. By using tags of EC2, you can translate those into actual grains, and then you can target those instances based upon that grain, which is really coming from their EC2 tag. You can also build in some metadata grains as well, pull some of the things from the EC2 metadata service and create grains from that as well. The Salt master also has a similar launch template. The one we're showing on the right is just a minion config. The master is pretty default and bare bones, so the only one I'm showing is the minion. So kind of like a summary, putting this all together with the diagram again, we can see that we make a change in Salt, gets pushed, committed, gets built into an artifact, really a code built, bundled up, deployed via code deploy to our auto scaling group of Salt masters. And in this demo that I'll show in a little bit, it's just one, but keep in mind this could be 10 Salt masters behind a load balancer. It would target as many as you want. Once the code is deployed onto the Salt master, it runs and basically fetches the private and public key for the master, so it stays consistent. And then it also, once it's all in place and ready to go, it updates the DNS record, and then the Salt minions can find the new one. So in this example, if we just made a change and we had an existing Salt master, the code would be committed, built, and pushed, get updated on the Salt master within maybe a minute or two. We'll time it in the demo, and then the minions would obviously apply their state, or its state would be applied within the time that we have configured, or you could force a high state to be applied. If this was a replacement, so let's say we killed the Salt master would obviously be launched. It would use its launch template to install Salt in the Salt master, and then once it was up and running, code deploy would see that this is a newly launched instance in the auto scaling group and automatically deploy to it. So we're talking within maybe 5 minutes of a launch of a new Salt master, you have code deploy automatically deploying to it. Once it's deployed, the configurations that are saved in code commit are pushed to the new Salt master, and then it updates its DNS record, and the minions find the newly replaced master. Leveraging some things like low TTLs, really low retries, and telling them to retry on a limited amount of attempts. Make sure that whether it takes 2 minutes or an hour for the Salt master to be replaced, that they'll keep searching and trying to find it. So I've talked a lot. Want to show a demo and actually show this in action. I'm going to minimize this here and pull up my. So this is my. Make sure I didn't lose anything here. So the first thing we have, I just want to show. So in this demo, I put this together because I can't share my actual team's work. So I put this demo together to kind of give a proof of concept in a normal AWS account. We can see here we've got 100 Salt minions running, a Bastion because we're using a VPC, and the Salt master. So the Salt master is hiding out here. you can see it's launched, it's running. So in this demo, we've got 100 minions, a Bastion, and one Saltmaster for a total of 102 hosts. As I kind of mentioned, we have auto scaling groups. In this case, we have one auto scaling group for our Saltmaster. For simplicity, it's just one instance, but there's no reason that it has to be that way. A Bastion just to let us get into our VPC, which is also a Salt minion. It's under control, and then our class of Salt minions. Maybe used in a more complex environment, you may have multiple auto scaling groups and just not a Saltmaster minion, but hopefully this demo at least conveys what's possible using these AWS services. So we kind of have this set up. The first thing I mentioned is code deploys and code pipeline. So we can see here, this is my previously set up pipeline, and we can see commits that get sourced, build, and deployed. So we're going to actually show first the CI/CD nature of this. So if we log in here, and minimize this, and close this for now. Cool. So the first thing we're going to do, we'll log into our demo. And we've logged into the Bastion. Right now, it's already been checked into the master and bootstrapped. We're going to log into the actual Salt master. So in this case, we use the Salt DNS record. And if we just look at you'll run and we look at all the minions that are up checked into this master, we can see that we've got 100, 101, 102 minions that are checked in. Let's see here, 101 minions that are checked into our Salt master. We'll keep that in mind later. But one of the first things we want to do is kind of, you notice when we log into the Salt master or any host for that matter, we've got this pretty message of the day that we'll use as the demo. So on my actual laptop now, I have a repo that's connected to code commit. And we can actually use that and go in and edit some of our Salt configurations. So in this case, what we want to do is go into our files, into this, and this is our little configuration for this pretty message of the day. So we can see here that you put in a little thing. Put this in here. Add a little message here so we can see it, commit it, push it. I will say that code pipeline is very robust for this demo. We're just using it simplistically. But once we get here, we'll be able to see within a matter of maybe a minute or less, we'll actually see our change get picked up and starting to build. As we can see right now, we've got, it's already been discovered. It's saying, hey, things have changed. Let me start this process. We can see it's kind of in that stage. Once it's done, it'll pick up our commit message and it'll pass it on to the build stage, as we can see. So our demo CI/CD code pipeline commit message made it as the newest version. It's being built and bundled right now, as we can see. You could make this really robust and include a lot of tests here. I didn't want to overcomplicate that for this demo, but Code Pipeline does have a lot of other cool functionality to make this even more robust and useful in other complex environments. We can see the code build is actually completed already. So we've gone from commit to build within, I haven't been timing it, but maybe a minute. And now we're actually targeting our Salt Master auto scaling group right now. We actually should have opened a tab, but if we go here, we can actually see that this deployment is in progress. It's kicking off. So to kind of walk you through, we've committed this to code commit. It's been built. It's now on the Salt Master, unpacked on the Salt Master. The Salt Master configurations are moved into their proper place. We start the Salt Master service again, and if necessary, in this case, it's not, because it's actually not a replacement. It's just a code push. We can see that it's succeeded, but in this case, it just it would update the DNS record, but in this case, it hasn't. We'll show that in a minute. So if we log back, if we go back here and we log back in, we're in our Salt Master. Let's just do, for simplicity, we'll just, this obviously you can set a high state to check in on a regular basis. For the interest of time, I'm going to just apply the state now. It's already running. We'll give it a second. Yeah. So there's already some configurations being applied. We'll let it finish, and then once it's done, we'll run it one more time just to be safe. So we have this. We've applied the state. We'll log back out. We'll log out of our bash and choose we're back into the repository. We'll SSH back into our demo. And as we can see here, it's a little unclear, but we've already had our change that we committed, pushed, built, deployed to the Salt Master, and then applied to all of our minions. We see, we log in here. In this case, the Salt Master is also a salted master, so it's a minion as well as a master, which also helps manage it. So it kind of showcases the CI/CD portion of it. That's really the key to being able to have the masters come up and down and stay in sync automatically. But the cool part here, we'll show you back on the master, just to keep me honest, we'll do so that we have 102 minions checked into the Salt Master. That includes the master itself and the bastion. So what we're actually going to do now, the actual fun part is, we're going to go back to our EC2 manager. And we're going to go here. We'll go here. What we're going to do is we're going to actually terminate our Salt Master. So we have it. It's been running. We only have one in our environment. It's the one we're just on. It has 102 minions checked into it. And we're just going to terminate it. We're going to say, you know, done with it for today, or I don't need it, or it's sick, or whatever we want to do. Whatever, for whatever reason, we have the ability to terminate it. We'll terminate it. And once the master is terminated, obviously the minions kind of are in a state of, well, I don't have a master. So within 5 minutes, we'll check back in on this, and we'll show that the Salt Master is the new Salt Master. And you can see here, just for fun, the old Salt Master's DNS record was 10.0.10.59. So on here, we'll put a little watch. So you can see here that the Salt DNS record is still responding to the old Salt Master's IP address, but once it comes back up and is successfully deployed, this should change to its new one. And while we're waiting, we'll kind of look at a couple of other key components here. So the first thing I really want to focus on is the actual launch launch templates for our, to be able to achieve this. We'll take a look at Minion first. The launch templates, as I mentioned, kind of are like the way to actually bootstrap the EC2 instance and actually show some. You can see by leveraging some of the metadata that we have, we can install Salt Minion or Salt Master in case of the Salt Master launch template. Some base configuration to allow the actual minions to actually find the Salt Master. I did find, and one of the reasons why this is a kind of an interesting component is that leveraging kind of the failover, but with one master. And there seems like there's a little bit of a bug there in terms of being able to have failover with only one. In this case, it makes sense. I think the failover was originally conceived as multi-masters for failover, but by leveraging an auto-scaling group, you could have one. So if you use master retries combined with the failover, it'll work. But if you just ship a basic configuration of just the Salt Master, this actually won't work because the minions will not, any newly launched minions would not find the new master. So you have to have some type of base configuration that says, because some of these configurations are not by default, master retries, the master type of failover, those things are those configurations allow this to happen. In this case, we're applying a high state every minute just for the demo. In this case, we kind of take some of the grains that we have and we create, some of the tags from our instance, and we create grains from them. So we can drop it off, and that's how we can target and say, this role gets this configurations, this role gets these configurations. In this case, we're just using its instance ID as a grain, its AZ as a grain, its region and role as a grain. Nothing too complex here for the demo, but then we have a couple other small things that just kind of help it start. And once this is all done, we start the Salt Minion. And once the Salt Minion is started, if there's no Salt Master, it'll keep waiting with these configurations, waiting for it to check in. So let's go back here while we're waiting, and let's check and see if 10.0.10.59, so I think that is still the old one. Let's just confirm that. So clicking around here. Pull up the Salt Master. We should have the Salt Master. We can see our old one was terminated. We have a new one that's coming online right now. So the launch, the auto scaling group noticed that the Salt Master that we terminated was missing. Said, hey, I need to launch another one. Our new address is 10.0.20.108. And I do want to say that you can launch masters using this approach in the auto scaling groups in any kind of AZ. So you can have AZ failure, fault tolerance, or something of that. So this isn't just limited to one AZ. By leveraging the auto scaling group and having it be in multiple AZs, you can launch your master wherever you would like in a specific region. So if we look here, we pull up code deploy again, and we actually go to the deployments. We should see that we don't have one yet. We'll have, this was launched 503. So it hasn't actually kicked off its deployment yet. Once the Salt Master is in a state where its good code deploy will actually deploy to our newly launched instance. And we'll see it in here. So you can see previous ones are listed under, where is it? Previous ones would be listed under auto scaling group action. So in this case, let's see, maybe that actually is done already. It actually just happened so quick, I didn't feel like it. Created 511. So yeah, so this has actually been pushed all the way through the pipeline. Our new Salt Master is already up and running. Code deploy is already pushed our configuration, specifically our new configuration, showing that it's showing off the CI/CD nature of code pipeline. And our Salt Master DNS record is updated already. So we've got, as we can see, this is the new Salt Master that we just launched according to this tab right here, 10.0.20.108. Cool. So we'll log in here. Log back into our new Salt Master. As we can see, our configuration that we pushed is already on the box. So that's really the source of truth, part of the allowing the Salt Master to come up and down. And then if we also do, now this may be because it's been so quick and we're pushing it really quickly for the demo purposes. Not all of the minions may have checked into the new master yet, but we'll check and see how many are actually running and already configured to check into our new master. So we can see, I'll do a word count in a minute, but we have clearly a good portion of minions already talking to the newly launched SaltMaster with our newly pushed configuration. Let's see here how many are trickling in. Right now, as we're waiting, like some of the minions are in several, they've all checked in already. So in previous demos, it's been a little longer. It's usually taken 5-10 minutes for the minions to actually check into the new SaltMaster. But in this case, we can see that this change got picked up pretty quickly, and all of our minions are now talking to the new master. So that's kind of it for the demo. I want to move on to full screen this again. So you're following along if something that interests you. I know there's a lot of services, a lot of things, but AWS has a large amount of good documentation that you can pull together. Some of these services before this demo I've had limited exposure with, so the documentation can definitely help you get in the right direction. And one of the most useful things I found is on the Salt documentation is the multi-master tutorial. That's also very useful and gave me hope that it was definitely technically possible. There are some things that AWS services can help with in that document, including if you look very closely at that tutorial, it says to make a copy of the keys in a kind of a warmed master spare, but leveraging Secrets Manager, you can get a lot of that functionality out of the box with AWS services. And with that, are there any questions?
Yeah, so if you're in the chat, we've got about 3 questions there. If you want to...
Let me pull it up. Let's see. It might look weird looking at the chat with my thing. Yeah, I'm sharing my screen for a second. So let me read some of these questions here. How are you removing keys? Let me see. That's a good one. How is pillar information provided to the master that can be distributed? Is it static? File which you're deployed to the package. So in this specific case, I'm not using pillars at all. So I have some like a portion of the demo or functionality that I have not used. We have different ways that we manage secrets. So I can't answer the question of leveraging pillars. The master is definitely configured to auto accept keys from minions. You could also get a little more fancy for demo purposes. We just auto accepted them, put it as true. And then that kind of falls into managing the keys. There's a cron that runs on the master every so often that purges dead minions and removes them. And then as minions come up and come down, they check in the master. And since it's in a VPC, this is somewhat a little less scary, I guess. They check in, the master accepts their keys, and when they haven't been seen for some amount of time, they get the keys get removed, and then whenever there's a newly launched one, it checks back in and repeats itself. Let's see, how are you moving keys? Is there any chance you could go over how you shared key acceptance across the masters again? So in this, yeah, we can talk about that. So Secrets Manager is an AWS service that lets you store anything that you want, whether it's a password, some kind of certificate, anything that you want to keep secret, you can store it there, and then you can fetch it with some AWS calls using whatever SDK you like. And in this example, we use Boto3 to actually fetch them. So you keep them in Secrets Manager, and on a deployment, it actually says, hey, I need to get these new configurations. I need to get these new keys. And it reaches out to Secrets Manager and says, give me the keys for this resource. And it'll give you the private key and public key, put them in the right place, and the Saltmaster picks them up. Let's see here. Instead of using DNS updates, could you front the master with an NLB for a static endpoint? Yes, I believe, yes, you can. In this demo, we don't, but you could put this. You could put your multi-masters behind a elastic load balancer and an NLB. You could have a pool of them. You could have 5 of them instead of just one. And you could then have the record point to Salt, have the NLB Salt point to the NLB, and then have your Salt masters check in to the NLB. And then you could also balance your load out that way. And by using code commit in the code pipeline, all of your masters will stay in sync as well. So you could do a rolling push to your NLB instead. So yes, it is very possible to use the load balancer, whether it's ELB or NLB. Both of those are very possible, and that's probably to do this in a more high availability way. I would definitely encourage that. So it's definitely possible. Let's see. I don't think there's any other. I think that's all the questions. Yeah.
Yeah, I think that's about it. Awesome. Well, Erik, thank you so much for your time. Thank you, everyone else, for.
Let me pull up my easy slide. I've got one more. I want to say thanks for letting me talk. I submitted this talk because I thought this was a cool idea, something that I didn't see in the documentation and that I didn't see much support for generally. As I mentioned, I did go into the Salt Slack channel, and I didn't get much traction there, but I was definitely committed and thought this idea was cool. And once I actually implemented it, I was happy with it. And then when I saw there was a conference for Salt to give a talk, I thought, hey, this might be cool. Maybe someone out there wants to leverage ephemeral Salt masters using AWS services. And so now that's what got me here. So I want to say thank you for letting me speak. And I want to thank all my coworkers at AWS for supporting me through this, and my family and friends as well. It's been an interesting undertaking. So
great. Yeah, thank you so much. All right.
Cool. Little early, but
no, you're great.
Cool. All right. Well, I mean, if there's any questions or any other things you want to ask outside, I'll be kind of around, lingering around in the lobby or watching some other talks if there's any other available. So feel free to reach out, message me if you have any other interesting questions or implementation questions, anything like that.
Awesome. Yeah, thank you so much. Great talk. Take care.
Yeah, thanks. Yep. Bye-bye.